Hello everyone, I am Pratyush, a third year student of BTech Engineering Physics at IIT Roorkee, and in this video I will be presenting about rotary encoders. Now here is an introduction to the whole presentation. We will understand firstly that a rotary encoder is an electromechanical device that detects rotational change and creates an electrical response for the same. Then we will see that they can be either absolute or incremental. We will also, based on their mechanical design, try to understand their categorization as optical, magnetic, and capacitive. Further, we will discuss in this presentation how optical encoders provide high resolution, magnetic encoders are more robust, and capacitive rotary encoders try to provide both the advantages. As we go along, we will discuss their respective advantages and disadvantages as well. A rotary encoder is an electromechanical device that detects changes in angular motion to create a corresponding electrical signal. The setup is so designed that it gives a precise information of the position and angular motion of the rotating shaft. Hence, a very basic requirement of this setup will be a rotating shaft with patterns and a detector to detect the same. This is also depicted in the slide. In general, it can be visualized that they are used for angular measurement, speed measurement, and position measurement. For these purposes, rotary encoders find their application in a wide range of industries. Rotary encoders can be either absolute rotary encoders or incremental rotary encoders. An absolute encoder has unique patterns for every location and hence can provide the exact shaft position at a given time. Here we can see that it is encoded from 0 to 7 in binary. Where the gaps get detected, it is considered as a 1, and 0 is encoded as absence of a gap. In incremental type, we can detect a certain number of pulses in every revolution. It can be used to measure the change in position and not the absolute angular position of the shaft. Also, based on the mechanical design, we have optical encoders, magnetic encoders, and capacitive encoders. We will discuss the structure as well as the applications of each type in the upcoming slides of the presentation. In an optical rotary encoder, there are LEDs which send photons to be detected by the photodetector assembly. When light passes through the coded disk, it gets detected and the electronics board finally generates an electric response. Hence, it uses light to detect changes in angular motion as well as the position of the shaft it is attached to. Optical encoders are used in a wide range of industries, including sawmills, paper mills, textile manufacturing, printing, packaging, etc. This is because they provide high resolution of motion and position detection. Some major applications of optical rotary encoders include application in robotics, automated guided vehicles, and servo motors. Robots are generally used in environments where human activity is not possible. Hence, it has very high demanding engineering requirements. An AGV or automated guided vehicle is a system that travels autonomously without a driver. As the need and importance of AGVs is increasing, we see that it can be considered as a major application of optical rotary encoders. Each motor in an AGV is combined with an encoder to record angle, position, speed, and linear distance. Along with this, servo motor controllers are provided with the necessary position feedback with the help of optical encoders. A servo motor encoder is responsible to detect rotation, like angle, speed, and travel distance of a moving machine. Magnetic encoder detects rotational position information as changes of the magnetic field, converts them into electrical signals and outputs them. Magnetic encoder has a shaft end configuration that combines a magnet magnetized in the radial direction. When the motor shaft rotates, The magnetic field created by the permanent magnet attached to the tip of the shaft also rotates. At this time, the magnetic field rotates with constant strength in the area near the center of the rotation axis. The Hall element detects this change of magnetic field distribution and converts it into an electrical signal. However, Hall elements detect magnetic field strength in only one direction, because of which we need two Hall elements to detect both Bx and By, that is magnetic field in x direction as well as in the y direction. The Hall elements convert the magnetic field information into electrical signals, which is converted to a digital signal using an ADC, which is an analog to digital converter. Finally, this information is used to find the angle theta. Now let us go through some of the applications and advantages of magnetic rotary encoders. So magnetic encoders detect changes of the magnetic field, which makes them robust in a contaminated environment, which makes it suitable for their use in environments with a lot of dust, oil, and water. For example, magnetic encoders are used in industrial sewing machines, which are used in environments with a lot of lint and machine tools, and where cutting, oil, and water splash are present. It also makes it possible to manufacture an encoder of a very simple structure consisting of a rotation angle sensor IC and a permanent magnet that outputs an absolute angle. This set is suitable for applications that require small size, lightweight, and high reliability. In general, we find that optical encoders are used in applications that require high precision and resolution, and magnetic encoders are used in applications that place importance on environmental robustness, small size, and high reliability. However, since the latest magnetic encoders have improved accuracy and resolution and are now compatible with hollow-through shafts, magnetic encoders are beginning to be used in the market occupied by optical encoders. Now let us see what a capacitive rotary encoder is. A capacitive encoder detects changes in capacitance using high-frequency reference signal. A capacitive encoder has three parts usually: a stationary transmitter, a rotor, and a stationary receiver. The rotor is etched with a sinusoidal pattern, and as it rotates, this pattern modulates the high-frequency signal of the transmitter in a predictable way. Finally, the receiver disk reads the modulations, and onboard electronics translates them into increments of rotary motion. In the diagram on the right, I have displayed two types of capacitive encoders, one with separate transmitter, rotor, and receiver, and the other with a combined transmitter, receiver, and a rotor. A major advantage of capacitive rotary encoders is that it offers resolutions as high as that provided by optical encoders, along with providing ruggedness as good as magnetic encoders. The reason is that it does not require an optical disc that makes it robust. This is also because it prevents the encoder from getting affected by contaminants present in the environment. Also, there is no need of an LED, hence no LED burnouts, which eventually increases its lifespan as compared to optical encoders. The major advantage is that it has the ability to change its resolution without changing the internal components of the device. All these advantages leads it to be used in major industries like semiconductors, electronics, medical applications, as well as in defense. Along with this, it is also believed that it may capture the applications where optical encoders are used in the future. With all these advantages, one must also understand that however robust they might be, there is also a concern that capacitive encoders are susceptible to noise and electrical interference. Now let us summarize the general advantages and disadvantages of the rotary encoders. In advantages, we see that rotary encoders provide a high resolution, high precision, high accuracy in measurement of angular position, speed, and direction. A fast response time makes them ideal for real-time measurement and control. It is a versatile device with a wide range of applications. Also, they are durable and reliable. And we notice that physical contact is absent between the sensor and the encoder, reducing the wear and tear of components and extending the life of the encoder. Along with this, it has certain disadvantages. Firstly, high resolution and high precision rotary encoders can be expensive. On top of that, the design of a rotary encoder can be complex, requiring additional hardware and software interface. Also, absolute rotary encoders have a limited range of positions that they can measure as they are encoded during the time of their manufacturing. I would also like to mention that even though we find that magnetic and capacitive encoders are more robust than optical encoders, we need to understand that they still can be sensitive to environmental factors such as temperature, humidity, and magnetic fields, which can affect their accuracy and reliability. Finally, I would like to thank you for watching this video.